In general, if block diagram is there, okay, if block diagram is given, how to reduce that block diagram to determine the overall gain we will discuss today. Okay, so then what is the need to reduce the block diagram is to determine the overall transfer function of the system. Okay, in order to determine the overall transfer function of the system, we have to reduce the block diagram, given block diagram. Okay, there are certain rules that are to be followed. Okay, there are certain rules that are to be followed to reduce the block diagram. Okay, so let us see these rules one by one. First rule, Amma, combining the blocks in cascade. Okay, so in this rule, if you see there is a block G1, another block G2. These two blocks G1 and G2 are connected in cascade. Means they are connected in series. Okay, so input for G1 block is A. Okay, so this G1 and G2 are nothing but, as we have already discussed, usually the transfer function values are represented within the blocks. Okay, so G1 and G2 are nothing but the transfer functions. Okay, when A input is given, okay, A is the input for this block G1. Okay, so if you want to determine the output will be the product of the input and the transfer function value. So what will be my output? A into G1 will be my output for this block. Output of this block G1 is A into G1, where G1 is the transfer function of this block. Now, A into G1 is input for G2. Okay, A into G1 is input for G2. A into G1 is the input for G2. Now, what is the output for G2? It is A into G1 into G2. A into G1 into G2 is the output for G2. Okay, so the initial input is A, the final output is A into G1 into G2. Okay, so even after reducing the system, or even after reducing the given block diagram, the initial input and the final output should not change. Okay, that we must make sure in our minds, that we must keep in our minds. Okay, so now whenever two blocks are connected in cascade or series, if I want to reduce those two blocks, simply I can multiply the transfer function values. So transfer function of this block is G1, transfer function of this block is G2. Okay, simply multiply, you will get a single block of G1 into G2. So initially input is A, final output is A into G1, G2. I hope it is very simple and clear to you to understand this. Okay, let us go for rule number 2. Okay, in rule number 2, okay, 1 minute, I want to make some modifications. It's not happening. Okay, in rule number 2, Amma, there are rule number 2 is combining parallel blocks or combining feed forward path. Okay, so either we want to combine the parallel blocks in rule number 2, or we want to combine the feed forward path. So you can see here, this block G2 is fed to the summing point, as well as G1 is also fed to the summing point, same summing point. Okay, so there is no return path towards the summing point. Okay, there is no return path towards the summing point. Both are directed towards the summing point. Okay, directions if you observe, both are directed towards the summing point. Okay, so these two blocks are said to be parallel. I will explain later clearly about what is meant by feedback path. Okay, in the next, while discussing about the feedback, there is another rule is there, rule number 10. There I will explain how to know whether it is a parallel path or whether it is a feedback path. Okay, so here you can see both these blocks outputs are directed towards the summing point. So these two blocks are parallel blocks. Whenever parallel blocks are to be combined, they must be added up. Okay, so initially before adding, let us see, input is A for G2, input is A for G1 also. For G2 as well as for G1, inputs are A. Okay, so what is the output? What is the output, Amma? Output for G1 is AG1. Okay, output for G2 is AG2. Both are here in the summing, here inside the summing point we can see plus the signs of these two outputs are plus, means they should be added. Okay, so from this whatever signal comes out from this summing point, that signal will be the addition of these two values. Okay, AG1 plus AG2. So you can take A common and you can write A into G1 plus G2. Okay, it is simple. Okay, now as I already told you, when two blocks are in parallel, if I want to combine those two blocks, simply the transfer function values of those two blocks must be added. So here in this single block, you can see G1 and G2 are added. Initially, what is the input? It is A. What is the final output? Okay, A into G1 plus G2. Instead of this, you can write A G1 plus A G2. It doesn't matter. Both are same. Okay, both are same. So, whenever I want to combine the parallel blocks or feed forward path blocks, then simply I have to add the transfer functions of those blocks. Okay. Anybody wants to ask? If you have doubts in between, you can unmute yourself and you can ask me whatever doubt that you have. Okay, it doesn't matter. Okay. So one thing you must make sure that initial input value and the final output value should not vary. Okay. Next rule number 3. Moving the branch point ahead of the block. Okay. So this is a branch point which is behind this block. Okay, behind block G, this is the branch point. So input for G is A, input for the signal which is coming from this branch point or takeaway point, we can say. Takeaway point, we can call this branch point as takeaway point. So through the signal also, A input goes to whatever location. Here nothing is shown here, so the signal coming through this point is A. Okay, input to G is A. So output of this transfer function will be A into G. Okay, A into G is the output. Okay, now, so what I want to do is I want to move the branch point ahead of this block. Means in front of this block. See, in front of this block. Okay, so what should be the output of the signal? It should be A. Okay, A should not change. A should not change. So it is moving ahead of the block means there must be some influence of this G. Okay, so if when it moves ahead of this block, there is a signal. AG signal is there. Okay, so if AG is given as input to this this signal, actually it should not be AG, it should be A only. A should not change. The final outputs and the initial input should not change. In between any changes can occur. I want only A, but I am getting AG because when this branch point moves ahead of this block, what happens from this location? From this location, signal starts. So means AG will be there, not A. So I don't want AG, I want only A. So I can add a block here in which I can write the transfer function as 1 by G, so that AG into 1 by G I will get A. So my initial input value and final output values are not changing, so I am satisfied. Okay, so the output should be satisfactory, means output should not vary even after combining the blocks. Okay, final outputs and the initial inputs should not vary. In between there may be any change. Okay, so a block of 1 by G must be introduced here so that GG cancel and only A is remaining. Okay, next rule number 4. Okay, in the rule number 4, we want to move a branch point before the block. In the previous case, we wanted to move the branch point ahead of the block. In this case, we want to move this branch point behind the block. Okay, so input for this block G is A. Okay, and output for this block G, what will be the output? A into G will be the output. Okay, there is a branch point from which a signal is coming out. So definitely the magnitude of the signal or the value of the signal will be AG only. Okay, so I want to move this branch point before this block. So my output should not vary for the signal. Okay, so if I move this branch point before this block, only the signal will have only A value. Okay, but I want AG. So what I should do is I must add one more block G so that A into G I will get AG. Okay, it is also very clear and simple. This is one more rule. Next rule number 5. Moving the summing point ahead of the block. Okay, this is a summing point. This is a block. I want to move the summing point. I'm sorry. I want to move this summing point after this block. Okay, so initially let us see there is a signal A coming toward the summing point, signal B is coming toward the summing point. Both will be added up A plus B. A plus B is given as input to this transfer function G. Okay, so transfer function into A plus B is my final output. Initial inputs are A and B. Final output is A, G plus BG, I can say. Okay, now I want to move the summing point to after this block. Okay, after this block, okay, after this block means what is the output here? A plus B, G. I must guess A plus B, G should not vary. Okay, so initially G is there. Okay, so from the A is one of the inputs. So now when summing point moves this side, A is the input to this G. So output will be AG. Okay, output will be AG that is given to the summing point. I must add something in such a way that one more, when I add AG plus I want BG. AG plus BG I want. So since I want AG plus BG, okay, I need one more block here, G block, so that output of this block will be BG. So when these two are added, I will get AG plus BG. Okay, so final output has not changed, initial inputs have not changed. Okay, so simply what you can remember is, whenever summing point is moved ahead of a block, okay, a transfer function of G value means whichever block, whatever is the transfer function of this block, whatever is the transfer function of this block, same transfer function will be introduced here. Okay, that you remember. Okay, rule number 6, moving the summing point before the block. The summing point is after the block. I want to move it before the block. So initially, let us see the input and output values. Inputs are A and B. Okay, so A into G, I will get the output of this block AG. AG is summed with B, so I will get AG plus B. So my final output should be AG plus B. I want to move the summing point behind this block. Okay, so summing point has moved behind this block. Initially A input, it has remained as it is. Okay, so here I have to introduce something in such a way that final value should be AG plus B. Okay, so I have divided. I have taken 1 by G value. Here only G is there. I have taken 1 by G value. Okay, so when I multiply it, I will get B by G. Okay, so I will get B by G. A plus B by G, I will get A plus B by G, I will get. Okay, this is the input that is given to this block, and this is the input given to this block. Okay, so when it is multiplied with this G value, I will get AG plus B. Okay, next amount. If it is confusing, I will once again, series and parallel is easy. Okay, once again I will tell you from rule number 3, if you see, in simple words, if you want to know, okay, in simple words, if you want to know, whenever summing point, I'm sorry, it's not summing point, it is the branch point. Whenever branch point is to be moved ahead of the block, a block 1 by G will be introduced in it. Whenever branch point is moved behind the block, a block G should be introduced in it. It should be inserted in it. Okay. Whenever summing point is to be moved ahead of the block, so whatever transfer function is there, same transfer function will come in this this signal. Okay. So whenever summing point is moved behind the block, 1 by transfer function value will come here. Okay, that you remember, it is more than enough. Okay, so no need to worry about the inputs and outputs. Simply if you remember those rules, it is sufficient. Interchanging summing point, Amma. So there are two summing points. This summing point has only summation values. This summing point has plus and minus values. So I want to interchange them. Okay. So A and B are the inputs to this summing point. So A plus B. C is introduced here. So A plus B minus C I will get. So final output is A plus B minus C. Initial inputs are A, B, C. Okay. So this summing point has moved here. So I will get A minus C. Okay, here nothing has to be introduced. Only summing point data change. Nothing will change. Simply, you need not worry for any output value. It is not going to change at all. Simply, you see, if you observe here, A minus C will get plus B. So A plus B minus C will get. Nothing is there. So need not worry about this rule at all. Okay, splitting the summing point. Okay, so here three signals are there which are added up at this summing point. Okay, so I want to split the summing point into two summing points. Okay, so I am considering two inputs A plus B. Now another summing point A plus B minus C. Okay, so nothing is there. Combining summing points among. So two different summing points are there. I want to combine them. See, just the opposite of this. No values will change. So one thing you can remember is that whenever we want to do any modification with respect to the summing points, there is no need to introduce any blocks. Okay, no need to worry about what will be the transfer function of those blocks and all. Okay, it is very simple. Okay, so I was in the last class I was telling you that in the case of negative feedback system, here we will get a plus instead of there will not be minus, it will be plus. How it is plus, we will discuss now by these equations. Okay, next rule number 10 is elimination of negative feedback loop. Elimination of negative. Are you able to hear my voice?
Yes, ma'am.
Yes, ma'am, it's audible now.
You are able to hear my voice. Okay then. See, rule number 10, Amma. Elimination of negative feedback loop. So see here. See, I was telling you in the earlier, it is a parallel path. This is a parallel path, isn't it? So you can see a signal towards the summing point, and the signal is also towards the summing point. Now let us differentiate between the parallel path and the feedback path. See here, the signal is moving away from the summing point, isn't it? And from this branch point, signal is returning back to the summing point. This is a feedback loop. This is a feedback loop. If this arrow which is moving towards the right, if it is towards the left, okay, suppose this arrow which is moving towards the right, if it is towards the left, then this will become a parallel path. Okay, so a signal should move away from the summing point, and from some other path it should return back to the summing point, then only it is a feedback path. Okay, that you remember. Now here, R is the input to the summing point. Okay, R is given as input. Okay, and an output of C is generated. Okay, for R input, C is the output. We know that in a feedback, whenever feedback is given, the output is fed back to the feedback element. Okay, so this is the feedback path transfer function is H. H is the feedback path transfer function of this block. So C will be multiplied with this H, I will get CH. Okay, it is a negative feedback. So feedback, negative feedback path, so minus is here. So the difference of these two, input R and CH, will be given to this block. This block means this block transfer function is the transfer function of the controller and the plant. Okay, of course. If we in detail, clearly if we want to understand, the difference of R and CH will be given to the controller. Okay, here we are discussing in terms of blocks, that's why we need to talk about controller. Okay, so R minus CH is given to G. Initially, when the process starts, only R is given. Initially when the input is given, only R is given. Okay, and some output is generated, that output is fed back, and when that output is fed back through this feedback element to the summing point. Okay, and the difference of these two is taken and that is given as input to the controller. Okay, R minus EH is given as input to this. So this is the transfer function G. So the input, this acts as the input. So this input into G will give me the output. Okay, so this output will be almost equal to C. Yes or no? R minus EH into G is equal to what? C. So C is what? C is equal to R minus EH into G. Okay, so I can expand it. I can expand. I can make this G to go inside this bracket. What I can write as C equal to R into G minus EH into GM. Okay. C is equal to R into G minus CH into G. So I can, whatever minus CHG can be sent towards the left hand side. Okay, when minus CHD is sent towards the left hand side, it will become C plus CHG equal to RG. Okay, so I can take C common, I will get 1 plus HG equal to RG. Okay, so if C by R will be equal to G by 1 plus GH. Okay, C by R equal to, C by R is nothing but transfer function. Yes or no? C by R is the transfer function. Okay, so G by 1 plus GH for negative feedback. So if I go for positive feedback, this will become minus. Okay, this will become minus. How it will become minus? Here plus will be there. So you will get what? R plus CH. Okay, here you will get R plus CH, R plus CH into G you will get. So R, C equal to R plus CH into G. I am talking about positive feedback loop, for positive feedback loop. This is for negative feedback. So if you go for rule number 11, if you go for rule number 11, elimination of feedback loop, a positive feedback loop, if you see, here the plus is there. Same terms except here plus R plus CH will be there in this case. Okay. So C by R equal to G by 1 plus GH. So what is our input? R. Output C. So what is the transfer function? Overall transfer function value is G by 1 plus GH you can write. So this is a simple block for this. It can be replaced by this block. Okay, this whole thing can be replaced by this block. Similarly for positive R is the input, C is the output, G by 1 minus GH. Here 1 plus GH, here 1 minus GH. Okay, these are all the rules for reducing the block diagram. Okay, to determine the overall transfer function of the system. If you have doubts, anybody can unmute and ask me. There are some steps to be followed for reducing the block diagram. Step number 1, initially, whenever a block diagram is given to you, okay, we must initially we must reduce all the series connected blocks. Okay, initially we must reduce all the series connected blocks. After that, we must reduce the parallel connected blocks. How we must reduce? We have seen the rules. Okay. Okay. Next, we must reduce the minor feedback loops. Means small feedback loops. Okay, there will be large feedback loops as well as small feedback loops. For solving the problems, it will be very clearer to you. You will be able to differentiate between small feedbacks and larger feedbacks. Next, step number 4, try to shift the takeoff point, means branch point towards the right, summing point towards the left. Always, okay? While solving the problem, always branch point you try to move towards the right, summing point towards the left. Okay? So repeat step 1 to 4, all these 4 steps till simple form is obtained and determine the overall transfer function of the system. So while solving the problem, these 6 steps you must sincerely follow. Okay? Anybody, if you have any doubt, you just ask me. You can unmute, or you want me to repeat anything which you feel that I am very fast. I don't know whether I am fast or slow. I am just teaching, that's all. If you want me to repeat, anybody? No, shall I proceed? Nobody is talking. Why?
Oh, ma'am, proceed, ma'am.
You want me to proceed? So all of
Ma'am,
you want to do is, I am going to solve the problems now. Okay? I am going to solve the problems. So you also solve along with me. It is very, very important. Okay, it is very, very important. These problems are very, very important, Amma. These problems are very, very important. So all of you solve these problems. Okay. So at any cost, you have to. Do you know that soon next month, final years exams are about to be conducted. Theory exams. Manually, they are going to come to college and they are going to write the exams. So don't neglect the online classes. Okay. I will forward till now whatever I have discussed today. I will forward all those topics in your classroom. Google Classroom mail ID. You go and your classroom. You go. There is a okay. There is a classwork title that is provided there. In that you go and see. I am providing all the materials. The whole unit is also there in that. Okay, let us see solve the problems. You people draw this diagram, all of you. I will bring water and come. One, you just draw it. Okay, you can see a block diagram here. Okay, so there are two summing points. Okay, and some transfer functions, no, not two, sorry, three summing points are there and some block transfer functions are represented in some blocks. Input is R of S, output is C of S. Okay, Amma? So initially, what you can do, what comes to your mind? So what we have seen just now, we have seen some steps, 6 steps. In those 6 steps, the step number 1 was to combine the cascade blocks or series blocks. So in this diagram, if you see, you can combine these two, G1 and G2 are connected in series. So initially, you combine G1 and G2. Okay, you can combine G1 and G2. So it will become a single block. Okay, it will become a single block. Okay, with the magnitude of G1 into G2. Okay, so here it will become G1 into G2. Okay, so step number 1. Step number 1, Amma, combining G1, G2 which are connected in series. You must write. Okay, I hope you people are writing. I will go very slowly. 5 more minutes are there. I will solve only one problem today. You have to write it down. This is not a classroom. Okay, so this is a virtual classroom. Okay, so it is in your hands. Okay, so you can see step now. You must write each and every step, Amma. You must write each and every step. So step number 1, combining G1 and G2 which are connected in series. So you will get like this. After that, if you see carefully, is there any parallel path? Is there any parallel path? So I think I can see a parallel path from G3 to summing point and G4 to summing point. This is a parallel path. You will get a doubt. There is a common branch point here. Branch points can be simply split, Amma. No need to go for any rule at all. Okay. So what I can see is a parallel path is there. So these two blocks are to be added up. G3 plus G4. Okay. Step number 2. Step number 2, Amma. combining G3, G4 which are in parallel. Okay, so simply combining G3, G4 which are in parallel. G3 plus G4. Okay, step number 2. Parallel blocks have been combined. G3 plus G4. You will get like this. Okay, I hope you people are drawing. I don't know whether you are drawing or not. I hope you are drawing. You have to draw. Otherwise, you can't understand. Okay, in step number 2, G3, G4 are added up. Okay, because they are connected in parallel. Now, next what I have to do? What I can see is, this is the arrow which has been started from this input. This will go up to this output. So there is an arrow here. Okay, so we must understand that. Okay, even if arrows are not shown in the diagram, what will be the arrow in this so and so signal? Okay, from input to output, the same line. Okay, so this arrow is from this summing point, it is moving away from the summing point. From this branch point, it is returning back to the summing point. Means this is a feedback loop. There is another loop also. There is another loop. See. Okay. So this is the larger loop. This is the minor loop. So we must reduce the minor feedback loops. It was one of the steps. Okay. This is a minor feedback loop. This is G. This is H. Okay. G is equal to what? G1 into G2. H equal to H1. So is it a feedback or positive feedback or negative feedback? It is negative. You can see here, it is a negative feedback path. It is a negative feedback path. Okay, it is a negative feedback path. So what is the transfer function? G1 into G2 by 1 plus G1, G2 into H1. See, G1 into G2 by 1 plus G1, G2 into H1. I will tell. Okay, so next step is reducing the feedback loop of G1, G2 and H1. Okay, reducing the, I think I can be more specific here, like introducing and subscript. It will be more clearer, isn't it? I can introduce and subscript. Meanwhile, if people can note it down or draw it down, you do whatever you want. I hope you people are following. I hope you people are following. If you have doubts, in between, unmute yourself and ask. Don't neglect these online classes. Suddenly, if they ask you to come and write the mid-exams, what will you do if you are neglecting? If anybody, I don't know. Whether you are listening carefully or not. Now, feedback loop has been reduced. Reduce the feedback loop. G1, G2 and H. I will get this transfer function. Okay? In this block. Now what I can see is these two blocks are connected in series. Since these two blocks are connected in series, simply I can multiply. Okay? So G1, G2 into G3 plus G4 by 1 plus G1, G2, H1. Next step is what? Step number 4 is combining the cascade blocks. Step number 4. Combining the blocks which are connected in series. So I will get this. Next, what I can see is from this arrow, this is the direction, this is the written one. It is a positive feedback loop. Okay, so this is a positive feedback loop. Okay, so reducing the positive feedback loop. I have written positive, you know the reason behind that. So I can, it's my vision, I can write anything. Step number 5. Simply I can say eliminating the feedback path. I can say reducing the feedback loop, or I can say reducing the positive feedback. Your wish, your problem, your wish. You can write any statement here. It doesn't matter. Okay, it doesn't matter. You can write anything. Okay, so it is a positive feedback loop. This is my G. This is my H. So for reducing a positive, this is the positive feedback. So what is the feedback value? What is the formula transfer function value for a positive feedback loop? What is it? G by 1 minus G into H. Okay, here my G is this value 1 minus this is G into H2 is my H value. Okay, I have got the overall transfer function. This is my input, this is my output, this is the overall transfer function. So what is my overall transfer function, Amma? Okay, I have further simplified it. Okay, numerator, denominator is there. You further simplify it, you will get this equation. Okay, so C of S by R of S, overall transfer function of the system. C of S by R of S is equal to this equation. Already 47. Okay, if you have doubts, unmute yourself and ask me. I'll take this snapshot. Okay. If anybody has doubts, unmute yourself and ask me. No doubts? Shall I take the attendance?
Yeah, ma'am, no doubt, sir.
Okay then, I will take the attendance. Okay, tomorrow also we are going to solve the problems. Day after tomorrow also we are going to solve the problems. Okay, so I don't know for how many days we are going to solve the problems, because today what I have discussed is a simple problems. Still many complicated problems we have to discuss. Okay, many problems have to be discussed. Okay, it's a very important topic. So very simple. If you know the concept, you will enjoy solving the problems. Okay, if you know the concept. If you don't know the concept, it will be a headache to you. 1 minute, I will stop the